Okay, number 47. Okay, first we find the first derivative, 16x minus 1 over x. And we want to find when that is equal to 0. And you could either set it equal to 0 right now and then cross multiply or get a common denominator. Either way, I'm going to get a common denominator. So if I have to multiply the bottom by x, there's another x up here. So I have 16x squared minus 1. That's my first derivative. Find my critical point, set the numerator and denominator equal to 0. Well, the numerator, that's going to equal 0. I can either factor it or just add 1 and divide by 16 and square root it. Either way. And you get that x is going to equal plus or minus 1/4. Okay. Now this denominator or this function is undefined when x is 0, but remember we can't really use the second derivative test when it's undefined. So I'm only going to be able to use the second derivative test for this, which means that in truth I really wouldn't do a second derivative test for this one. So I was about to do my first derivative test to show it to you when it occurred to me that we have a natural log here. So remember, you can't take the natural log of 0, so that's gone. And you can't take the natural log of a negative number. All of this is gone. So the only number you're really going to check is the 1/4, which means either a first derivative test or a second derivative test. Either one will work. Okay, since I already have my first derivative sign chart here, I'll go ahead and just do it since I have it here. Okay, plugging in surrounding the 0 and the 1/4. If I plug into the right of 1/4, I could plug in a 1. And that would be positive. To the left of 1/4, if I plugged in, say, 1/2, 1/2 squared would be 1/4. I get a positive there too. Hold on, let me double check my math. I'm stupid. You can't plug in 1/2. 1/2 is not to the left of 1/4. I would need to plug in something like 1/16 or 1/8 or something like that. So if I plug that in, you'll find that your first derivative is negative. So using a first derivative test, don't keep in mind I'm doing the wrong test. This isn't what they asked for, but you should get the same results either way. Using the first derivative test, there's a min at x of 1/4 because the first derivative changed from negative to positive. Now, second derivative test, you really shouldn't have done any of that. With the second derivative test, I take this 1/4 and plug it into the second derivative. So I need to find the second derivative. I'm going to use this format of my first derivative. I think that's easier. My second derivative would then be 16. This is x to the negative 1 with a negative in front. So that would be positive x to the negative 2 for this. That's my second derivative. Now, regardless of what I plug in, I'm supposed to be plugging in my positive 1/4. Regardless of what I plug in here, that's always going to be positive. So what does that tell you? If the first derivative at 1/4 was 0, but the second derivative at 1/4 is positive, which means concave up, then 1/4 is a min. That's the second derivative test. Okay, so again, I wanted to show you the first derivative test because I honestly think that might have been a little bit quicker and you have to know it anyway, but you should not have had to do anything that was in red here. All of that was the first derivative test. In blue is the second derivative test. And again, the other issue with this problem, you can't take the natural log of 0 or a negative number. Hope that helped.